A warm welcome to everyone in my video. My name is Sisek Suba, bearing roll number 20NS0345, student of Sikkim Government College Namchi, Physics Department under Sikkim University. This video basically carries 25 marks for our Sessional B, Paper 6. Firstly, I would like to express my special thanks of gratitude to HOD of Physics Department, Sabat Sir, and Dr. Sipi Khatewara, and all the faculties members for their able guidance and support in completing my assignment. I would also like to extend my gratitude to the Principal Sir Dr. Tiwari and to my parents for providing me with all the facilities that was required. So the topic which I will cover in this video is about Bose-Einstein condensations and sputtering technique. So moving on to the video. So before starting this topic, Bose-Einstein condensation, म के भन्न चाहन्छु भन्दाखेरि म यो जुन मोस्ट अफ द टपिक चाहिँ म आफ्नो रिजनल ल्याङ्ग्वेजबाट एक्सप्लेन गर्छु, जुन चाहिँ नेपाली ल्याङ्ग्वेज हो. इफ तपाईहरुले त्यो ल्याङ्ग्वेज बुझ्नु भएन चाहिँ आई एम एक्सट्रिमली सरी. So my topic is Bose-Einstein condensation. Bose-Einstein condensation is a state of matter of a dilute gas of bosons cooled to temperature very close to absolute zero. Under such conditions, a large fraction of bosons occupy the lowest quantum state, at which point microscopic quantum phenomena become apparent. र यहाँनिर एउटा वर्ड आएको छ त्यसो चाहिँ हो बोसोन्स. एक्चुअली बोसोन्स भनेको चाहिँ के हो भन्छ यो चाहिँ एउटा सब एटोमिक पार्टिकल्स हो उसको जसको चाहिँ स्पिन क्वान्टम नम्बर एन्ड हेज एन इन्ट्रिकल भ्याल्यु 0, 1, 2 हुन्छ. त्यसलाई चाहिँ बोसोन्स भन्छ. र यो जुन स्टेटमेन्ट हुन्छ यो स्टेटमेन्टले के भन्दैछ भन्दाखेरि चाहिँ स्टेट अफ म्याटर्समा सोलिड, लिक्विड, ग्यास, प्लाज्माहरू हुन्छ. त्यस्तै एउटा बोस-आइन्स्टाइन ग्यास हुन्छ. जब बोस-आइन्स्टाइन ग्यास चाहिँ टेम्परेचर चाहिँ क्रिटिकल टेम्परेचर भन्दा कम्ती हुन्छ त्यति बेला चाहिँ यो जुन एक्साइटेड स्टेटमा चाहिँ जुन चाहिँ त्यो नम्बर अफ पार्टिकल्सहरू हुन्छ त्यो एक्साइटेड स्टेटबाट सबै ग्राउन्ड स्टेटमा झर्छ. र जब चाहिँ त्यो ग्राउन्ड स्टेटमा चाहिँ त्यो एक्साइटेड स्टेटबाट आएको पार्टिकल्सहरू थुप्रिँदाखेरि चाहिँ त्यहाँको पपुलेसन बढ्छ र त्यो इन्क्रिज इन द्याट ग्राउन्ड स्टेटमा चाहिँ त्यो पपुलेसन जुन चाहिँ इन्क्रिज हुन्छ र त्यो चाहिँ क्रिटिकल टेम्परेचर भन्दा बिलो हुन्छ. त्यसलाई नै चाहिँ बोस-आइन्स्टाइन कन्डेन्सेसन भन्छ. र इन द इयर 1924 एन्ड 25 सत्येन्द्रनाथ बोस जो चाहिँ इन्डियन फिजिसिस्टहरू हुन्छ उसले चाहिँ एन्ड अल्बर्ट आइन्स्टाइनले चाहिँ प्रिडिक्ट गरेको थियो यो स्टेटलाई चाहिँ. So the next topic is derivation for Bose-Einstein condensation. The total number of particles for a perfect Bose-Einstein gas is given by n equals to v by h cube 2 pi m k to the power 3 by 2 a plus a square divided by 2 to the power 3 by 2 plus a cube divided by 3 to the power 3 by 2 plus dot dot dot. यो इक्वेसन चाहिँ के भन्दै चाहिँ दिस इज द इक्वेसन फर टोटल नम्बर अफ पार्टिकल्स फर अ पर्फेक्ट ग्यास. सो इन दिस ए इज नोन एज डिजेनेरेसी प्यारामिटर. र यो डिजेनेरेसी प्यारामिटर भनेको चाहिँ के हो भन्दाखेरि चाहिँ द्याट इज द डेभिएसन इन द बिहेभियर अफ बोस-आइन्स्टाइन ग्यास फ्रम द्याट अफ अ पर्फेक्ट ग्यास इज कल्ड डिजेनेरेसी. यो भन्नाले के बुझ्छ भन्दाखेरि चाहिँ जब बोस-आइन्स्टाइन ग्यास चाहिँ को बिहेभियर चाहिँ पर्फेक्ट ग्यासको बिहेभियरसँग डेभिएट भयो चाहिँ त्यति बेला चाहिँ त्यसलाई चाहिँ डिजेनेरेसी भन्छ. र त्यही हो ए भनेको त्यही हो डिजेनेरेसी प्यारामिटर. सो पहिला चाहिँ हामी के गर्छौँ भन्दाखेरि चाहिँ जब यो डिजेनेरेसी प्यारामिटर चाहिँ भेरी भेरी लेस देन 1, सो फर ए विच इज भेरी लेस देन 1 त्यति बेला चाहिँ यो इक्वेसन 1 लाई चाहिँ हामीले के लेख्न सक्छौँ भन्दाखेरि चाहिँ n इक्वल्स टु v बाई h क्युब 2 पाई mkt 3 by 2a. किन यति मात्रै लेखेको भन्दाखेरि चाहिँ ए चाहिँ धेरै धेरै कम्ती छ 1 भन्दा. किनभने अब यो जुन चाहिँ यो पोर्सनमा चाहिँ स्क्वायर छ या यसमा क्युब छ त्यति बेला चाहिँ अब स्क्वायर क्युब भनेपछि चाहिँ हाफ भन्दा पनि कम्ती हो. अब हाफ भन्दा कम्ती हो भनेपछि यहाँ अगाडि भनिरहेछ ए इज लेस देन 1 भन्दाखेरि चाहिँ हाफ कम्ती हुन्छ. त्यसले गर्दा हामीले यो दुईटालाई नेग्लेक्ट गर्छौँ. अन्ली यो ए मात्रै लेख्छौँ. त्यसैले गर्दा यो पोर्सनमा यो यति मात्रै आएको यो दुईटालाई हामीले नेग्लेक्ट गर्छौँ. So now this we will cross multiply this equation so that we will get a equals to n by v h cube by 2 pi m kt 3 by 2. र यो इक्वेसन पाउँछौँ हामीले. र यसमा चाहिँ यो इक्वेसन के छ भन्दा यो डिजेनेरेसी प्यारामिटर चाहिँ जुन चाहिँ डाइरेक्टली प्रोपोर्सनल टु n by v. n by भनेको ए चाहिँ डिपेन्ड्स अपन n by v. त्यो चाहिँ हो नम्बर अफ पार्टिकल्स पर युनिट भोल्युम. पर युनिट भोल्युमसँग चाहिँ डेभिएसन यो डिजेनेरेसी चाहिँ डाइरेक्टली प्रोपोर्सनल हुन्छ. तर इन्भर्सली प्रोपोर्सनल टु टेम्परेचर. किनभने जब चाहिँ टेम्परेचर हामी इन्क्रिज गर्छौँ तब यो डिजेनेरेसी प्यारामिटर डिक्रिज हुन्छ. इफ डिजेनेरेसी प्यारामिटर इन्क्रिज गर्यो भने चाहिँ टेम्परेचर चाहिँ डिक्रिज हुन्छ. यसरी भएको हुन्छ. र यही कुरा चाहिँ यहाँनिर हामीले लेखेछौँ. सो वेन देयर इज इन्क्रिज इन पार्टिकल डेन्सिटी n by v, a or decrease in temperature, the value of n increases, and hence there is derivation of Bose-Einstein gas from ideal gas behavior. So next we will do for ground state. पहिला हामीले a less than 1 को लागि गर्यौं. So now second we will do for a equals to 1. यो equals to 1 भन्दाखेरि चाहिँ what will be the equation 1? Equation 1 मा के हुन्छ भन्दाखेरि चाहिँ n equals to b by h cube 2 pi m kt power 3 by 2 1 plus 1 square by 2 to the power 3 by 2 plus 1 cube divided by 3 to the power 3 by 2 plus dot dot dot. यसमा के भयो भन्दा चाहिँ जब यो a को जग्गामा हामी 1 हाल्छौं यो इक्वेसन 1 मा when we will put equals 1 in this place त्यति बेला चाहिँ के हुन्छ भने यति हुन्छ र यो म्याथमेटिकली चाहिँ यतिलाई चाहिँ हामी क्याल्कुलेट गर्दाखेरि चाहिँ 2.612 मात्रै आउँछ. त्यसैले गर्दा हामी क्रस मल्टिप्लाई पनि गर्छौं र n by v यहाँ आउँछ. त्यति बेला चाहिँ इक्वल्स टु 2 pi m kt to the power 3 by 2 by h cube 2.612 मात्रै आउँछ. यति हो यो यति म्याथमेटिकल एक्सप्रेसनको भ्यालु चाहिँ 2.612. Now the temperature at which particle density is maximum is called critical temperature. So thus at T equals to Tc, now we have to put Tc in the place of T. So the equation will be n by V max equals to 2 pi m k Tc by h cube 3 by 2 2.61 by 2. That is equation 2. So now we have to cross multiply this equation 2 and we will get nh cube by V 2.61 equals to 2 pi m k Tc by 3 by 2. So now we also have to transfer this power 3 by 2 to the left hand side. So it will be nh cube by v 2.612 to 2 by 3 equals to 2 pi m k tc. So now we have to take tc from this equation and we will get the value of tc, that is 1 by 2 pi m k nh cube by v 2.612 to the power 2 by 3. So this is the value of tc. So now we have to go for Bose-Einstein energy distribution law. So using this equation, that is Ni equals to Gi e to the power alpha e to the power beta ui minus 1. So this is the equation for Bose-Einstein energy distribution law. So this is the excited state and this is the ground state, and naught is the number of particles in ground state and Ni is the total number of particles in the excited state, and ui is the energy of ground state, which is always 0, and this Gi in this equation is the number of quantum state, which is always equals to 1. So here it is, for ground state ui equals to 0 and Gi equals to 1. So number of particles and not in the ground state are given by n naught equals to 1 by e alpha dot e naught minus 1 and not equals to 1 by to the power alpha minus 1. So this is the equation when we put this value over this equation. So now we will find the total number of particles, which we will get by adding the total number of particles in ground state and total number of particles in the excited state, that is n equals to n naught plus n1, which is equation 3. And this equation which we have wrote already in equation 1 is similar to this. n1 equals to b by h cube 2 pi m kt to the power 3 by 2 a plus a square 2 by 3 by 2 plus a square divided by 3 by 2 plus dot dot dot. So from this equation हामीले चाहिँ के रिमुभ गर्नुपर्छ भन्दाखेरि चाहिँ we have to remove यो t लाई चाहिँ यो ब्र्याकेटबाट we have to take this out and it will be n1 equals to b by h cube 2 pi m k to the power 3 by 2 t to the power 3 by 2 plus a square 2 by 3 by 2 plus a square by 3 by 2 plus dot dot dot. So after doing that, n by v equals to 2 pi m k t c 3 by 2 by h cube into 2.612. So this equation is similar to equation 2, which we have wrote already over here. This is the equation which is similar to this. So same yanera pani we have to take tc outside. So it will be n by v equals to 2 pi m k 3 by 2 divided by h cube tc 3 by 2 into 2.612. Now we have to cross multiply this equation. So it will be n by tc 3 by 2 into 2.612 equals to v by h cube t pi m k 3 by 2. Now this is the equation 5. सो अब चाहिँ के गर्नुपर्छ भन्दा युजिङ इक्वेसन 5 इन इक्वेसन 4 वी गेट. सो हामीले यो इक्वेसन जुन चाहिँ इक्वेसन 5 विल बी युज दिस इक्वेसन 5 इन इक्वेसन 4. एज वी नो द्याट दिस इज सिमिलर टु दिस. त्यो जुन चाहिँ इक्वेसन 5 मा b/s3 जुन चाहिँ आएको छ दिस इज सिमिलर टु दिस. सो वी विल पुट दिस इन ओभर हियर इन इक्वेसन 4. सो इट विल बी n1 इक्वल्स टु n/tc 3/2 into 2.612 t to the power 3/2 a plus a square 2 3/2 plus a cube divided by 3 3/2 plus dot dot dot. So now we have to do for equals to 1 we have. So अब चाहिँ के गर्नुपर्छ भन्दा we have to put this value of a that is 1 in this equation. So now we will get n1 equals to nt by 3/2 divided by 2c 3/2 into 2.612 1 plus 1 square 2 3/2 plus 1 square 3 3/2 plus dot dot dot. So we have already know the value of this mathematical expression, that is 2.612. So it will be n1 equals to nt 3/2 into 2.612 tc 3/2 into 2.612. So after this we will get the equation n1 equals to nt 3/2 by 2c 3/2, because this 2.1612 and 2.162 will be cancelled out. So the remaining is this. This is the equation 6. So now as we know that the power of t and tc is similar, that is 3/2. So we can write over here that is n1 equals to n/2 by t to the power 3/2, that is equation 7. So now using equation 7 in equation 3 we get n equals to n1 plus n t by tc to the power 3/2. So it will be n0 equals to n minus 1 n by t by tc 3/2, n0 equals to n 1 minus t by tc 3/2. So this is the equation and the derivation for Bose-Einstein condensation. So my next topic is sputtering technique. Sputtering involves vaporizing materials from a solid surface by bombarding a target with high velocity ions of an inert gas, which causes ejections of atoms and clusters. This means it is a kind of physical process in which a vaporization occurs in a solid materials by bombarding it by ions energy. So this sputtering technique is carried out in vacuum so that it can work smoothly. And even positively, negatively, as well as neutral charge clusters are produced. While doing this technique, this following charge and clusters are produced, and even the target materials may be some alloy, ceramic, and compound. These compounds are being used while doing these techniques. And sputtering can also be done in high plasma pressure, that is 5 to 30. And this technique was first discovered by English physicist W.R. Grover in the year of 1852. So the next topic is type of sputtering. There are many types of sputtering, but we will study only DC direct sputtering and RF direct sputtering. So DC direct sputtering is also known as direct current sputtering. It's a thin film physical deposition (PVD) coating technique where the target material to be used as the coating in bombardment with ionized gas molecules, causing atoms to be spattered off into a plasma. DC sputtering is basic and inexpensive types of sputtering. So this is definitions and why DC sputtering is used. The reason is it is basic and inexpensive. So the next topic is RF direct sputtering. So RF direct it allows the sputtering of dielectric material. Adoption of an AC discharge makes the two electrodes equivalent. One electron is bombarded in one part of the cycle and the other in the remaining part of the cycle. So this is definition for RF direct sputtering. And why we use RF direct sputtering is it is widely used in industrial process because of high quality films and can be obtained at low temperature substance. So this is the reason why RF direct sputtering is used. So thank you.